we always get excited about those big, shiny new rockets and the missions happening right now.
Right.
But what if I told you some of the most interesting discoveries are actually coming from looking back, way back,
Okay.
into NASA's massive data archive.
Yeah.
Think of it like a treasure trove of data.
Like a digital attic.
Yeah.
Yeah.
Waiting to be explored. And that's actually what we're doing today. We're going to dive into how NASA's incredible data archive is still leading to new scientific breakthroughs.
Yes.
Even decades after the data was first collected. And we're talking over 100 petabytes of data.
Wow. That's a lot.
Yeah, it's hard to even fathom how much information that is.
It truly is remarkable, just this wealth of information seemingly just sitting there, but the potential is huge.
Right.
As our ways of seeing things evolve and as our tools get better, the past efforts pay dividends.
Right.
In surprising ways.
Yeah, and we're talking about things like finding hidden moons around Uranus. From decades-old Voyager 2 data, confirming water ice on the moon using the LRO.
Yeah.
Historical data, and even like pinpointing lost Mayan cities on Earth using airborne data from years ago. It's really incredible.
It really is. The sheer variety of these discoveries should give you a sense of just how rich this archive truly is.
Absolutely. And our mission in this deep dive is to really unpack this for you, to show you not just what these amazing finds are, but also like how they're happening and why this information is so valuable.
Right.
Especially now with powerful technologies.
Right.
Like artificial intelligence.
AI is really changing the game.
It really is. It's changing the game for analyzing all this data and finding new things.
Absolutely.
We're going to explore how this archival data is crucial in areas like space weather.
Yeah.
Monitoring the climate, and even planning for future lunar missions. So get ready, because we're about to reveal to you the surprising power held within NASA's digital vaults.
To really appreciate it, we first have to grasp the scale. 100 petabytes?
Right.
It's almost unfathomable.
Yeah.
Kevin Murphy, NASA's chief science data officer, said it best, I think.
Yeah.
He called it one of our most valuable legacies.
Yeah, it's more than just numbers and data points.
Right.
It's a really detailed record of countless missions and experiments.
Absolutely.
Observations.
Experiments in space.
Yeah.
Observations from Earth.
Yeah.
Observations from all over the solar system.
Right, and all just waiting to be uncovered. To put that 100 petabytes into perspective for you, it's like 20 billion smartphone photos.
Wow.
All in one place.
That's a lot of selfies.
Yeah, and that number just keeps growing.
They're constantly growing. Every day.
Every single day, yeah.
As new missions are launched.
Yeah.
As new data is collected.
Yeah, so it's not just data gathering dust.
No.
It's a living, breathing resource.
Absolutely.
A living archive.
And more than half of all scientific papers that use NASA data rely on this archived information.
That's right.
That's incredible. It's not just for historical reference.
Right.
It's informing current science.
Yeah.
It's helping us understand our universe.
Researchers, governments, even commercial entities are using this data all the time.
And for you, it's important to realize this data covers a really wide range of scientific disciplines.
Yeah.
I mean, think about it. Astrophysics.
Yep.
Distant galaxies. Black holes.
Huge amounts of data there.
Yeah. Biological and physical sciences.
Right.
Experiments conducted in microgravity.
Yeah.
Earth science. Understanding our planet's systems.
Yeah.
Climate patterns. Ocean currents.
Yeah.
Heliophysics.
Right.
The sun.
Yeah.
Its influence on the solar system.
Yeah.
And planetary science.
Of course.
Other worlds.
Yeah.
Each of these 5 divisions within NASA
Yeah.
holds petabytes of information,
Yeah.
all being continuously examined
Right.
to understand our universe.
Let's look at a specific example. Something that might surprise you. Let's talk about Uranus,
Uranus. Okay.
the planet that spins on its side.
Yeah.
Back in 1986,
86?
Voyager 2
Yeah.
flew past Uranus.
Right.
Gathered a ton of data. Major achievement.
Huge achievement at the time.
But the story didn't end there.
The story continues.
Fast forward to the early 2000s.
Okay.
Scientists using advanced image processing techniques on that same data from 1986
Wow.
discovered 2 previously unseen moons,
No way.
Perdia and Cupid.
Wow. talk about finding something in the attic after all those years.
Yeah.
It's a perfect example of how technology can unlock old data.
Right.
I mean, the initial analysis of those Voyager 2 images was groundbreaking.
Groundbreaking, yeah.
For its time.
Yeah.
It was amazing.
Yeah.
We saw Uranus up close for the first time.
Yeah.
But our ability to process images has improved so much.
So much, yeah.
That we're able to find these fainter, smaller objects.
It makes you wonder what else is hiding in that data.
Right.
I know.
And the story doesn't stop there.
Oh, tell me more.
In 2024,
Okay.
researchers went back to that same Voyager 2 data and identified an interesting event involving the solar wind.
Okay.
That happened as Voyager 2 was flying by.
Okay.
The solar wind compressed Uranus's magnetosphere.
Oh, wow.
Which is the planet's protective magnetic bubble.
Right.
That shields it from radiation.
So this compression of the magnetic field wasn't something they even knew was happening at the time.
It was happening during the flyby.
Wow.
But they didn't realize it at the time.
Wow.
But this compressed magnetosphere gave scientists a unique opportunity to study Uranus's magnetic field under unusual conditions that they wouldn't normally observe.
Right.
So if you picture those artist renderings of planets with their magnetic field lines extending out, this event basically showed that field being squeezed.
Wow.
Compressed.
That's really interesting.
It's a fantastic example of how this archival data can reveal rare phenomena that might have been overlooked but are actually crucial for our understanding of planetary physics.
It's like the data held a secret. Right. We just didn't have the key to unlock it.
We didn't have the right tools.
Yeah, until now.
Okay.
Let's shift our focus a bit.
Okay.
From that icy giant to our closest celestial neighbor.
Right.
The moon.
Boom.
The Lunar Reconnaissance Orbiter.
LR.
Has been doing amazing work since 2009.
Yeah.
Constantly sending back data.
Yeah.
But how does its archival data play a role?
So the LRO is a prime example of a mission that keeps giving.
Right.
It just keeps enhancing our understanding through its data.
Yeah.
But the archival data has also proven incredibly valuable.
Oh, really?
Yeah.
In what way?
For instance, back in 2018, scientists analyzed years of LRO data and definitively confirmed the presence of water ice in those permanently shattered regions at the moon's poles.
Yeah.
Now, this is huge.
It is huge,
for future lunar missions.
Yeah, because they could potentially use that water ice.
Exactly. Imagine future astronauts being able to access water on the moon.
Right, because those craters are so cold that any water that gets trapped there could last for billions of years.
Yeah, that's right.
So it's a long-term resource.
A potential long-term resource.
Yeah.
And this year, 2024, researchers at NASA Goddard took another look at LRO data.
At the archival data.
Yeah.
That's right.
And they found evidence of water ice in other permanently shadowed regions.
Oh.
Outside the lunar South Pole.
Oh, so it's more widespread than we thought.
More widespread potentially than we thought. Yeah. This is big.
Yeah.
For future exploration.
And resource utilization. On the moon.
Right. And all this just by looking at old data.
Right. And all this just by looking at old data.
It just shows you we can keep learning from the data we've already collected.
Yeah. And that data is impacting future space travel.
That's right.
I mean, that's incredible.
Yeah.
So we've talked about Uranus. We've talked about the moon. Let's come back down to Earth now.
Okay.
Literally.
Back to Earth.
Yeah. It's fascinating to think that NASA's space data can help us understand our own planet.
Right.
In new ways.
Yeah.
Like the lost Mayan city.
Oh, yeah.
That was a really cool story.
That's a fantastic example of the unexpected insights that can come from these archives.
Right.
In 2024, archaeologists identified a previously unknown Mayan city.
Wow.
In Campeche, Mexico.
Wow.
How'd they do it?
Yeah, how'd they do it?
Airborne Earth science data.
Wow.
Specifically a data set from 2013.
Okay.
From NASA Goddard's.
Okay.
LiDAR hyperspectral and thermal imager.
Right.
Mission.
GLPIHT.
GLIHT.
Yeah.
So this advanced technology uses lasers and different wavelengths of light to create these detailed 3D maps
of the
ground.
Yeah.
Even through dense jungle foliage.
Wow. So it can see through the trees.
You can see through the trees.
That's amazing.
It's amazing technology.
Yeah.
And it revealed these structures hidden beneath.
Wow. It's like something straight out of an adventure movie.
Right.
But instead of a dusty old map, they're using cutting-edge NASA data.
Exactly.
I love it.
It's incredible.
Yeah.
To think a mission designed to study ecosystems could lead to this discovery of a lost civilization. It just highlights the interconnected nature of scientific data and how what we learn in one area can impact another seemingly unrelated area.
Yeah, and it's not just uncovering the past.
Right.
NASA's Earth science data is also crucial.
Very important.
For understanding change that's happening today.
Yes. Present-day changes.
Like the Harmonized Landsat and Sentinel-2 projects.
Yes.
HLS. This combines data from multiple satellites.
That's right.
To provide frequent high-resolution observations of Earth's surface.
Think of it as like snapshots.
Yeah.
Detailed snapshots of our planet.
Right.
Regularly.
It gives us these detailed, up-to-date views of our planet.
Yeah.
Which must be really useful for tracking things like deforestation, natural disasters.
Exactly. Things that affect all of us.
Right.
And it's not just new data.
Right.
We have data going back decades. With the Landsat program.
Yeah.
So we can look at changes over time and get a long-term perspective.
Right.
This is really valuable for tracking things like urban growth.
Oh, interesting.
Yeah.
Okay.
So, for example, researchers have used these archival Landsat images to study how cities have expanded and how infrastructure has developed. And it shows how our landscapes have been transformed over time.
Yeah. You had a good example about Ontario, California.
Yes.
Can you tell me about that?
So if you look at Landsat 5 satellite images of Ontario, California from 1985 and compare them to images from 2010, you'll see a huge change.
Right.
The city has grown massively.
Wow.
You can see how the airport expanded.
Yeah.
They built new runways to handle more air traffic.
Right.
And a lot of the rural areas around the airport were replaced by warehouses and commercial buildings.
So a lot of development.
Lots of development, yeah. And even the vegetation changed.
Oh, wow.
As the landscape became more urbanized.
Yeah.
So by analyzing this data, researchers can not only document this urban sprawl, but also identify trends and predict future growth.
Right.
Which is important for urban planning, resource management, and understanding how our society is changing.
Right. So it's not just about space, it's about how we live here on Earth.
Exactly. It's about us, our planet, our future.
Okay, so we've talked about looking back with existing technologies.
Right.
But the future seems to lie in AI.
Yeah, AI is going to be huge.
Yeah.
For unlocking NASA's data archive.
Right.
And making even greater discoveries.
Yeah. NASA's making big investments in AI.
They are.
Especially AI foundation models.
That's right.
Now, these are advanced AI tools.
Yeah.
Designed to go through these huge data sets.
Right.
With incredible speed.
Yeah. They can identify patterns and make connections.
Yeah.
That would take us forever to do manually.
Right.
AI is much faster.
So much faster.
And much more efficient.
Yeah.
At this kind of analysis.
Kevin Murphy talked about developing one AI model.
At least one.
At least one.
Mm-hmm. Yeah.
For each of NASA's scientific disciplines.
It's a really ambitious goal.
It is, but imagine.
Yeah.
Decades of data.
Yeah.
Turned into this treasure trove of discovery.
It's an exciting prospect.
I know. And this isn't just a pipe dream.
No, it's happening now.
Yeah. NASA's collaborating with IBM and universities.
Yeah.
To actually develop these AI models.
And importantly, they're making sure these models are scientifically validated.
Right.
And adaptable.
Right.
So they can be used for different data sets.
Right. So they're not just limited to one specific thing.
Exactly. They can be applied to lots of different research.
I like that.
Yeah. It's like having a virtual assistant.
Oh, yeah. Murphy said that.
Yeah.
It's like having a virtual assistant.
That can leverage all of NASA's knowledge.
Right.
And help us make decisions.
Smarter and quicker decisions.
Yeah.
Can you give some examples of how these models are being used right now?
Sure.
Okay.
In Earth science, they've developed the Prithvi geospatial model and the Prithvi weather model.
Right.
These AI tools analyze massive data sets from satellites to monitor our planet, track weather patterns, and support decision-making in areas like disaster response.
Yeah, that's really important.
It is.
Yeah.
Agricultural planning, resource management.
Right.
All things that affect you.
Affect all of us, yeah.
So, for example, the Prithvi model was trained to detect burn scars.
Oh, wow.
From wildfires. Using data from Landsat 8. We saw this in the East Peak fire in Colorado.
Right.
So instead of scientists spending hours manually analyzing images, the AI can do it much faster.
So much faster, yeah.
And more accurately. Providing information to those who need it.
Right.
Much faster.
Almost immediately.
Almost immediately, yeah.
That's incredible.
It really changes how we respond to these events.
Yeah. It makes things much more efficient.
Yeah, much more efficient.
Yeah. And they're also working on a heliophysics foundation model.
That's right.
To understand solar activity.
Yes.
And space weather. Which is so important because solar flares and other space weather events can disrupt our technology.
That's right.
Satellites, power grids.
Yeah.
Even astronauts in space.
Absolutely.
So this model could help us predict and prepare for those events.
That's the goal.
Yeah.
To better understand space weather.
Yeah.
And protect our technology.
Yeah, that's so important, especially as we become more reliant on space-based infrastructure.
Exactly. We rely on these systems more and more.
And you mentioned a model for lunar data, too.
Yes.
So a lunar foundation model is in development.
That's right.
And the goal there is to understand lunar resources. Like the water ice we talked about, as well as the lunar environment in general. This is going to be crucial as we plan missions to the moon.
It's going to be very valuable.
Especially if we want to establish a long-term presence.
A permanent presence on the moon. That's the ultimate goal. To have humans living on the moon.
It's like science fiction becoming reality.
It really is.
Yeah. And all this is possible thanks to AI and these vast amounts of data.
That's right. Data and technology working together to advance our understanding.
I feel like this investment in AI is going to lead to a whole new era of discoveries.
I think so, too.
Yeah.
It's an exciting time.
It really is.
For science.
It's not just about gathering more data.
Right.
It's about maximizing the value of what we already have.
Exactly. We have so much data.
Yeah.
We need to make the most of it.
Right.
And AI can help us do that.
So NASA's data archive isn't just some static record of the past.
No.
It's a dynamic resource.
A living archive.
Yeah, that's a good way to put it. A living archive that's constantly evolving and yielding new insights.
Absolutely.
And a lot of that is thanks to AI.
And the brilliant scientists who are working with it.
Right.
Analyzing the data. Finding those hidden gems.
It's incredible that we're still finding new things from data collected years or even decades ago.
Oh, it's amazing.
Like the moons around Uranus.
Yeah.
The lost Mayan city. New insights into space weather.
Right.
All from old data.
It makes you wonder what else is out there.
Yeah, it really makes you think, if this is what we're finding now, what will we find in the future?
What secrets are hidden in the petabytes of data being collected right now?
Yeah. What do you think is waiting to be discovered?
The possibilities are endless.
I know, it's so exciting to think about.
The data being gathered today could hold the answers to questions we haven't even thought to ask yet.
It's mind-blowing.
It is. It's a future full of incredible discovery.
I can't wait to see what we find.
Me too.
Thanks for joining us for this deep dive into NASA's data archive.
It's been a pleasure.
Yeah, it's been great.
Really interesting.
Yeah. Until next time, keep looking up.
And keep exploring.